Assalamu alaikum students and welcome to another lecture of Slate. This is Khawaja Yasin. Let's study chemistry. So when we talk about A-levels chemistry, especially in the physical chemistry, the chapter of chemical energetics holds some good importance. And why is that so? Most of the chapter, I would say some 32% of the chapter is similar to whatever you've studied in O-levels. The concept of endothermic reaction and the exothermic reaction, bond breaking, bond making, the energy profile diagram, the bond energy values, finding the enthalpy change. So I will not be talking about those concepts. If you want to go through those concepts, I have the link of my O-levels lecture on chemical energetics, one crash course lecture for all those concepts. But in today's video, we will talk about the standard enthalpy change and how to calculate the standard enthalpy change through another method. Now there are different methods in A-levels. One is by the MC delta T equation and the other is through the Hess law, in which we will talk about in the next lecture. And we will practice some good amount of questions because that can be tricky. But in today's lecture, this is going to be a little basic because for A-levels chemical energetics, you need to know a few definitions. This whole chapter is built on these 8 definitions. And on the basis of these definitions, you will be solving the questions. If you don't remember the definitions, there is no point of attempting the questions. So, first of all, what is standard enthalpy change? This is not just enthalpy change. This is standard enthalpy change with a mark on it. So this tells us that we are talking about the standard enthalpy change. So enthalpy change under standard conditions. It's as simple as that. But what are the standard conditions? Just like chapter 4 of states, gases had those standard conditions. Likewise, when we talk about standard conditions for enthalpy change, pressure should be 1 atm or 10 raised to power 5 pascals. Temperature, 25 centimeter cube or 298 Kelvin. In this chapter, we are free of the Kelvin or Celsius thing. It's the same thing. I will tell you why. Concentration, it should be 1 mole per dm cube. And physical state, a very important part of both the reactants and products should be the ones that they have on room temperature and pressure. So for instance, if we have water as a compound, we will be talking about water as a liquid, not water as a gas, not water as a solid ice. Sodium as a metal. So that is what we know about enthalpy change and the standard conditions under it. Now we have various definitions, and I dare tell you that you have to memorize those definitions. Ratta chahiye. And even the concepts are very important. So first of all, the more we get into the details of the definitions, the more further we go, हमें उतना समझ आएगा कि how important and what are we going to talk about in these definitions. So first definition, a very basic one, standard enthalpy change of reactants. Reaction. Or the enthalpy change, it can be heat lost or absorbed or gained, endo or exo both, when molar quantities of reactants as stated in equation react to form products under standard condition. So bachcho, 1 mark is fixed for this under standard conditions. You can mention the conditions if you want to, or you can just write under standard conditions. That's perfect. Now in this case, we are just talking about reactants. It can be elements, it can be products. And we're talking about molar quantities as stated in the balanced chemical equation. So there is no rocket science, a basic balanced equation. So enthalpy of reaction, it can be of all the reactions in the world. A particular amount of reactants making a particular amount of products. For example, now let's see these two different examples. 1 mole of nitrogen reacts with 3 moles of hydrogen to make 1 mole of ammonia. That's an exothermic reaction. It can vary. Likewise, even it goes normally in the other direction where calcium carbonate is dissociated. But all I need to tell you is that even the two compounds, 1 mole of both compounds, can also make a product. So these two are enthalpy of reactions. They're generic. Abhi tak there is no rocket science, no confusing concept, just enthalpy of any reaction. Any reaction. But when we talk about standard enthalpy change of formation, something is being formed. So we need to keep a few things in mind. What are the things? The enthalpy change when 1 mole of a compound is formed. 1 mole of a compound needs to be formed from its element in their standard states. Now, this is not applicable here because 2 moles of compounds are formed, but elements are there. Remember, elements, N is not an element, N2 is the element, Cl2 is the element. So, 1 mole of a compound needs to be formed from its elements under standard conditions. For example, this is the reaction of making sodium chloride. Now, students, if you balance the equation, sodium and chlorine, 2 elements, make sodium chloride. That's good, but we are not having 1 mole. So this is wrong. So what do we need to do? We need to have just 1 mole of Na. Constituent elements should be the same. Then we have to balance the equation. We need to have 1 mole of this one. So what I can do is 1. So I'm divided by half. If you find it difficult, there is a shortcut for you as well. If 2 is the issue, so you divide all of them by 2. This becomes 1, this becomes 1, and this is half. So that can also be done. Likewise, now 1 mole of carbon dioxide needs 1 mole of oxygen and 1 mole of carbon. Carbon solid. Why carbon solid? It's graphite. So this is also being formed from its elements and 1 mole of a compound is formed. Ammonia. Now we made ammonia here. 2 moles. We need to make 1 mole out of it. The reactants will be the same. So how do we easily do that? Let's balance the equation in the right way. Now this is 2 ammonia. There are 2 ammonias. I just want 1. So I divide this side by 2. I divide this by 2. And I divide this by 2. So ultimately this becomes 1 mole, and this is the accurate equation for the formation of ammonia. Ethanol, very commonly given in the exam, very commonly. Now how many carbons do you see? 2 carbons. How many hydrogens? 5 and 1, 6. So hydrogen is H2. So we have 3 moles of H2 gas plus just 1 oxygen, while oxygen exists as O2. So we just take a half of it. Sodium phosphate, easily 3 sodiums. It's a metal, so it's a solid. 1 phosphorus and 2 moles of O2 gas. We made calcium carbonate here from calcium oxide and carbon dioxide. But that is just a reaction going on. That is not formation. Although 1 mole of calcium carbonate can be formed, was being formed, but we need elements. So what are the elements? 1 mole of calcium solid, 1 mole of carbon solid in O2. So how many oxygens? 3. 3 divided by 2. So that is how you make an equation for standard enthalpy of formation. Now, standard enthalpy change of combustion. You know, it is always heat loss because combustion is always exothermic. So, or you can just write enthalpy change. Now, there has been a confusion among students while balancing an equation of combustion where we make oxygen as half, 3.5, 4.5. Why not make a whole number? Well, this is the reason. Heat lost. So enthalpy change when 1 mole of an element or a compound, it can be an element or a compound, is burned completely in excess of air under standard conditions. So, under standard conditions, so 1 mole of methane is burned in air to form carbon dioxide and water, which is the combustion product. So, 1 mole of carbon, 1 mole of carbon dioxide, 4 hydrogens, so 2. Ultimately, we balance the oxygens, so that's what it is. If we talk about ethane, let's balance the equation. 2 carbon dioxides, 3 waters, and ultimately we have 7 oxygens on the right side. 4 here, 3 here. So how do we make it 7? We cannot make it a whole number because at the end of the day, we need just 1 mole of these. So I've written one thing, element or compound. Even elements can undergo combustion. For example, if I combust 1 mole of carbon in oxygen, I get carbon dioxide. If I combust 1 mole of hydrogen in half mole of oxygen, we get 1 mole of water. 1 mole of sulfur in 1 mole of oxygen, I get 1 mole of sulfur dioxide. Now elements are being combusted, forming their combustion products. Students, these are combustion products. But there is one more thing. Element forming 1 mole of a compound. Element forming 1 mole of a compound. Element forming 1 mole of a compound. In combustion, we were talking about 1 mole burning in oxygen, excess. But here we are talking about formation as well. So students, these 3 reactions are both enthalpy change of formation, enthalpy change of combustion. If you are given a value of enthalpy change of formation of carbon dioxide, that is equivalent to the value of enthalpy change of combustion of carbon. If you are given the value of enthalpy change of formation of water, that's equivalent to enthalpy change of combustion of hydrogen. And likewise, sulfate and sulfur. So in these 3 equations, it's the same thing. Examiner can confuse you, and we will solve such questions. Enthalpy change of neutralization, heat lost. So what does that mean? Neutralization is also always exo. Just like combustion was also always exo. While this is just enthalpy change. Formation can be endo or exo. Combustion is exo. Neutralization is exo. So heat lost when an acid reacts with an alkali, we know that, to form 1 mole of water. So 1 mole of NaOH reacts with 1 mole of HCl, forming 1 mole of NaCl, 1 mole of water. Perfect. But when we talk about 2 moles of NaOH reacting with 1 mole of sulfuric acid, 1 mole of sodium sulfate, but 2 moles of water. That's not right. So we need to divide this whole equation by 2. To make it enthalpy change of neutralization, because it is always about 1 mole of water. That becomes a valid equation. So in enthalpy change of neutralization, we talk about 1 mole of water being formed, students. Enthalpy change of hydration. Enthalpy change when 1 mole of a gaseous ion is dissolved in water to get an infinitely dilute solution. Now this is a new term, infinitely dilute solution. But there is not much rocket science behind it. By that, what do we mean? A solution where we have ample excess of water, where all the gaseous ion is dissolved. We study more about it in A2. But if I have 1 mole of a positive sodium ion, I get 1 mole of a sodium positive aqueous ion. 1 mole of a Cl aqueous ion. 1 mole of air. So ultimately, from 1 mole of a gas ion, we get 1 mole of a hydrated ion. That's what we get. Somewhat similar to that. Here we are talking about separate ions. A gaseous sodium making sodium ion, aqueous. A gaseous chloride making aqueous chloride ion. But there is another one, enthalpy change of solution. We will correlate these two concepts in Hess law and especially in A2 with lattice energy. But abhi ke liye, just the definitions. Enthalpy change when 1 mole of a solute is completely dissolved in water. Solute. To get an infinitely dilute solution under standard conditions. 1 mole of a solute, for instance. If we add 1 mole of an NaCl, what can we get? We get 1 mole of an NaCl aqueous solution. We know that. But aqueous sodium chloride, what does it have? It has aqueous sodium ion and aqueous chloride ions. So, again, correlation. You can be given such questions, students. Now, standard enthalpy change. Before that, if you notice, in hydration, we just make ions from aqueous ions from gaseous ions. Here we get aqueous ions from a solute, a solid. Solute. So these can be correlated through a triangular Hess cycle. Last definition, standard enthalpy change of atomization. Enthalpy change or heat absorbed, making atomization endo. When 1 mole of a gaseous atom is formed from its element under standard conditions, for instance, 1 mole of a gaseous atom, we have sodium solid. What will it give? It's going to give us sodium gaseous. Remember the gaseous atom in the first chapter? Ionization energy. When 1 mole of electron is removed from a gaseous atom, this was the gaseous atom. That's how we got the gaseous atom, through enthalpy of atomization. So standard enthalpy change of atomization is when 1 mole of gaseous atom is formed. So Br2, liquid. So I will not just be breaking the bonds. I will also be changing the states. Here we are going to break the Br bonds. So I get 2 Br gaseous atoms. But that's wrong. 1 mole of a gaseous atom. So what do? We divide this by 2 and we get 1 mole of a bromine gaseous atom. Likewise, hydrogen divided by half, and that's what we get. 1 mole of a gaseous atom. So students, before I conclude, let's correlate this concept of atomization with ionization energy. So ionization energy is also enthalpy. Standard enthalpy change of ionization energy, similar definition. When 1 mole of a gaseous atom, you have 1 mole of a gaseous atom. So what is standard enthalpy change? of ionization energy. Remember, it is also endo. Energy required to remove 1 mole of a gaseous atom, 1 mole of an electron from 1 mole of a gaseous atom to make 1 mole of a monopositive ion. So standard enthalpy change of ionization energy. We had solid sodium, we got a gaseous sodium through enthalpy of atomization, and ultimately that sodium went through in standard enthalpy change of first ionization energy to make a gaseous sodium ion. That is also a concept correlated with it. So this is all for the first lecture. I repeat, you need to know about the definitions, about the amount, about the moles. Only then can you do it right. Otherwise, there are chances of error. So thank you so much, students. In the next lecture, we are going to talk about the calculation of enthalpy change through the Q equals to MC delta T formula. So thank you so much. See you in the next lecture. Allah Hafiz.